Good day everyone, I'm Melissa and I'm here to teach you about collisions. Collision is the movement that happens when a moving object comes into contact with another object over a relatively short time. And physics has a lot to say about collisions. To figure out what happens when two objects collide, we must take into account these two main qualities, momentum and impulse. Momentum is the object's mass times its velocity, or in equation form, P is equals to m times v, where P is the momentum. On the other hand, impulse is a change in momentum and it also describes the force times time interval it acts over, or in equation form, F times t is equals to the change in mass times velocity. And in collision, we have this what we call impulse-momentum theorem, which describes the relationship between impulse and momentum. If you apply force to an object, it will gain momentum. For some duration of time, it will gain a proportional amount of momentum. If it loses momentum, then it must be imparting force to something else over some time duration. Another result of this theorem is that force given to moving objects as it impacts any surface would be very large if the impact is instant, and much less if the impact requires some time duration. This is why airbags are invented to slow down your moving body during the collision or gradually put you in a stop. The maximum possible force will then be imparted towards the airbag and therefore lessens the impact of the collision. We must note that in collision, total momentum is conserved. Therefore, the momentum before and after the collision is still the same. Now, we will talk about the two types of collision, the elastic and inelastic collision. Elastic collision is also called an ideal collision since it happens very rarely in real life due to forces that may come into play such as friction, gravity, and air resistance. In elastic collision, objects involved remain separate. Kinetic energy is neither created nor destroyed, and no damage is done to the object. We can see elastic collision in billiard games. For example, when the white ball hits the resting red ball, it sets the red ball in motion. Having transferred all of its momentum and kinetic energy to the red ball, the white ball comes to a rest. The net momentum of the white ball before the collision is equal to the momentum of the red ball after the collision. But if the ball travel at the same speed and collide head-on, they will bounce off of each other at the opposite direction with the same momentum. Their momentum and kinetic energy is transferred and conserved. In inelastic collision, momentum can easily be determined since we can treat the two objects as one after the collision. The momentum is equal to the sum of the two individual momenta, illustrated by the following expression: m1v1 plus m2v2 is equal to the sum of the masses times v final, which will depend on the magnitude and direction of the two individual velocity. An example of which is a car collision. Note that during inelastic collision, much of the kinetic energy is converted into sound energy, which we hear is the sound of the crash, as well as heat energy and the internal energy of the new system, which allows the body to deform as a result of collision. After the collision, they continue to move together at approximately half the speed only because its mass becomes heavier, therefore preventing it to move faster, so the total momentum stays the same but some of the kinetic energy is lost because less speed is involved. And that's the basic on how collisions move and how they relate to momentum on a straight line.